Good morning, friends. In the previous class, we have learned about the analysis of the example particle in a box and how we are analyzing it using the Schrodinger equation and the calculation of energy and the Eigen functions, Eigen values and Eigen functions. I think before that, we need to just revise the energy eigenstates, how the energy level diagram look like. If you remember, we already, yeah, this is how, like, increasing energy. Okay, here you have energy, and this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, etc. Okay, it goes like that. So as n increases, the separation between various energy levels increases. So I will call this one the ground state, first excited state, second excited state, third excited state, like that. It goes like that. Okay, so this is the energy level diagram. Energy level diagram. Now let me plot how the wave function, if we plot the wave function, how it look like. The corresponding to the ground state will look like this. So I'll call psi 1 when n is equal to 1, and for psi 2, let me draw it here. Okay, don't compare the levels because I'm just drawing it because it should look legible, that's why. Okay, this is the form of wave function, the shape of wave function corresponding to psi 2, and this one corresponds to psi 3. So here you have psi, and here it corresponds to x equal to 0 to x equal to a. Okay. Now, if we plot mod psi square, okay, here I am going to plot mod psi square. As you know, mod psi square represents the probability. So for n is equal to 1, again the same thing. Okay, I think I should draw it in proper way. Okay, so this is mod psi 1 square. This is again from 0 to a. Okay, now for the second one, you will have probability is only having positive values. Here you will have a node. So mod psi 2 square. And here you will have it should come to the same level. Okay, so mod psi 3 square. So this is the form of the mod psi square, and how the function psi and mod psi square varies, and this is the energy level diagram. Okay, now you know that the variation or the how the probability is getting varied if as en increases. This corresponds to n is equal to 1, n is equal to 2, n is equal to 3. Now let us move on with the problems. And now you have the idea of how it yes. Okay. Okay, let me go with the first one, first problem. First problem is that find the probability that a particle trapped in a box of length L or L, capital L wide, capital L, that is instead of A we have L. Okay, can be found between 0. So it is mentioned that the particle is found between 0.45 L and 0.55 L. 55 L. Okay. For the ground state and first excited states, we have to calculate the probability for n is equal to 1 and n is equal to 2. Probability, yeah, probability for n is equal to 1 and n is equal to 2. So what we have to do? For that we have to first write the general equation. If we write the general equation, for probability is integral psi star psi. So for that we should know the wave function. Our wave function is we already determined the value of wave function, that is psi n of x. Psi n of x is equal to the constant a is square root of 2 by, here instead of a we have L sine n pi x by L. Okay, so instead of a you have to write L. That's the only difference. Okay, now coming to the calculation. So probability is integral psi star psi dx. So our limit is already given. You are supposed to calculate probability from 0.45 L to 0.55 L. Okay, so this is equal to, you have to apply the values of psi star. So integral 0.45 L to 0.55 L. Psi star, there should be a constant 2 by L. Psi star means psi sine n pi x by L, then again constant 2 by L sine n pi x by L dx. Okay, now constant can be taken outside. Okay, let me write constant 2 by L outside, because we have two square roots of 2 by L. So 2 by L is taken outside. This is the general case of probability. Okay, we haven't mentioned whether we are calculating n equal to 1 or n equal to 2. Okay, so this is the general value of probability. Okay, so integral 0.45 L to 0.55 L. Now sine square, you should have sine square n pi x by L dx. Now when we have a sine square function, what we are going to do is we will convert it into cosine, that is sine square x is equal to 1 minus cos 2x by 2. You have to use that identity. Sine square theta is equal to 1 minus cos 2 theta by 2. So we are going to use this identity. Okay, so it will be integral, 2 by L is there, integral 1 minus cos 2 n pi x by L into dx, the whole divided by 2. Okay, so this 2 get cancelled. Okay, now okay, so what remains is p of p is equal to integral 1 by L is there, 0.45 L to 0.55 L, then 1 minus cos 2 n pi x by L dx. Okay, now what you have to do is integrate the value, integrate and apply limits. So 1 by L is there, first term is integral dx, so x, give the limits 0.45 L to 0.55 L. Now minus the second term, when you integrate, integral cos x is sin x, so give the value again, 1 by L is already there outside. Now sine 2 n pi x by L divided by 2 n pi by L, and you have to apply the limit 0.45 L to 0.55 L. Okay, now at this stage we can also, if you want, you can apply the limits 1 by L 0.55 L minus 0.45 L minus, I'll take 1 by L inside into L by 2 n pi, because we have a constant in the denominator. Okay, now sine values, you apply the values of sine, sine 2 n pi x, instead of x you should give 0.55 L by L minus, let me write the square bracket itself, sine 2 n pi into 0.45 L by L. So L get cancelled in both the terms. Okay, now you have here also L will be cancelled. Here also the L will be common and it will get cancelled. Okay, so what is remaining is 0.55 minus 45 and also the sine values. Now Okay, let me write the difference. 0.1 L by L minus the constant is 1 by 2 n pi into sine 2 n pi 0.55 minus sine 2 n pi 0.45. Okay, now at this stage you can give the value of n so that you can have probability of ground state and first excited state. So I'm going to give the value P n is equal to 1. So that is equal to, the first term remains like this, L is already cancelled. So first term is 0.1 itself minus 1 by 2 into 1 into pi, then sine value sine 2 pi into 0.55 because n equal to 1 here, minus sine 2 pi into 0.45. So if you apply the values and calculate, you are going to have the value of n is equal to 1 like this. Point 1 here, okay, 0.1, and you have plus, from the second term you will have 0.3074. You please calculate the sign values and apply the pi to all the values and find the value properly, plus 0.3104. So if you add all 2 pi also you will have. Okay, this one is correct. Okay, so from first term 0.1 you will have 10% and the second term you will have 9.8%. So the probability of the particle to be found in the first ground state is 19.84. So let us plot it. If you plot, we can plot it like this. If you remember, mode for the case of psi 1 square, we had this one. So if we give the values 0.45 L, this is 0 to L. Okay, 0.45 L to 0.55 L. So between these two lines you will have the probability. So this is what we have obtained as a 19.84%. Now we have to calculate the second case when n is equal to 2, that is for the first excited state. Okay, for that we have to go back, sorry, you have to begin with this equation. So okay, P of n is equal to 2. P of n is equal to 2. So our equation will be first term minus 1 by 2 into 2 pi, then sine 2 into pi into 0.55 sorry, 2 into 2 into pi, because 2n pi it is, minus sine 2 into 2 into pi, 0.45. So if you calculate this value, you are going to get the second term. First one is, as we know, it is going to be 10% because we already have calculated it. And the second one is going to be like this. Okay, let me just remove the percentage. Point 1 minus 0.58495 minus 0.5901 whole divided by 4 pi. In the previous case, you had 2 pi. Okay. So when we calculate it, you will get 10% from the first term minus 9.13%. So in effect, you will have only 0.87%. So let us check how it look like. So our plot is actually this one. So yeah, I should draw it properly. It may go like this one and this one. If I draw it properly, I think this line may go through this way. Okay, so I will have these portions. Yeah, what I am drawing is not that perfect. So you will have only this part. Okay, so this probability is 0.87%. So I hope you understood. So when you are asked to calculate the probability of a particle in a box from a certain region, it is given from 0.45 to 0.55 L of a box of side L, capital L. So first of all, what we have done is we have done the calculation of probability in a general way. Sorry. Okay. So for calculating the probability in a general case, we have written the wave function sin of x. We have already calculated it. So it is square root of 2 by L into sin n pi x by L. And for probability, what we have to find is P of n equal to 1 and n equal to 2. That is the probability of a particle to be in the ground state as well as probability of particle to be in the first excited states. If, okay, so I think we are going to what we are going to calculate is this one. So point 0.45 to 55. Okay, this is the first probability. What we have is the 19%, and this is the second probability. We have 0.87%. Okay, so for calculating these probabilities, what we have done is initially we wrote the probability general equation. The limit given is 0.45 L to 0.55 L, and we have applied the values of the psi star and psi. Constants are taken outside. Square root of 2 by L into square root of 2 by L is 2 by L, and the limit for 0.45 L to 0.55 L, then sine square n pi x by L dx. Now sine square cannot be integrated so easily, so to make the integration much more easier, we are applying this equation: sine square theta is equal to 1 minus cos 2 theta by 2. So you will have two different terms in the integral, and okay. So applied the limit, integrated the term and applied the limits, and you have this final equation. Now, if you check the equation, you will notice n in the equation. So we have to find the probability for n equal to 1, that is the ground state probability. So we have applied the values and determined the value as 19.84, and also for P of n is equal to 2, that is for the first excited state, and we have obtained it as giving n equal to 2, we have obtained it as a 0.87%, and we have plotted it. So I hope you understood the idea behind the probability calculation, because we already have that representation of a wave function. Yeah, so from this you will get the idea about what we have done. Okay, so this is a plot of a wave function, this is a plot of the probability. So we are actually finding the numerical value of this area, okay, for n equal to 1 and n is equal to 2. Now let us go for another problem. I think we are going to calculate the expectation values. Yeah, let me read the problem. Find the expectation value of the position of a particle trapped in a box of side L or a L width. So we have to calculate the expectation value of a position. That means we have to find expectation of x. Expectation of x, and that is defined as integral 0 to L psi star x psi dx. So this is the definition of expectation of x. We have the wave function, so you can apply the values. Integral 0 to L, psi is square root of 2 by L sine n pi x by L, then x again square root of 2 by L sine n pi x by L into dx. So take the constant outside, square root of 2 by L into square root of 2 by L is 2 by L. Then integral 0 to L sine square, x sine square n pi x by L dx. Now, first you have to write the simpler form of sine square n pi x by L. We already know that 2 by L into integral 0 to L x into 1 minus cos 2 n pi x by L divided by 2 dx. Okay, dx. Now you have to multiply with the x, 2 by L. Now you have two integrals, 0 to L x. Yeah, this 2 can be taken outside, so that can be cancelled. Now integral x dx minus integral 0 to L, constant is common here, okay, x cos 2 n pi x by L dx. Now first term, if you integrate the first term, you are going to have a, wait for a minute. Okay, integrate the first term. As we have done previously, it will be 1 by L is the constant. Let me take it outside. Okay, integral x is x square by 2, and apply the limit 0 to L. Now the second term. For the second term, you have to do integration by parts. So first function into integral of the second is sine 2n pi x by L divided by 2n pi by L between the limit 0 and L. I think this one should be made curly brace. Okay. Then this is, oh, actually we already have minus here. Okay. So I think better we write 1 by L along with each term. Otherwise it will be confused, I hope. Okay. So I'll write 1 by L here itself. 1 by L. Okay. Minus 1 by L. Okay. Now, first function into integral of the second minus integral of derivative of first. That means 1. D by dx of x is 1 into again integral of the second sine 2n pi x by L divided by 2n pi by L dx. Now, if you apply limits here, this term may not exist. Okay, because if you apply upper limit, you will have n pi multiples of 180 degree. So this term will be cancelled. For the second term, you already have x equal to 0. So you need not worry about this term. This term is going to be 0. So don't worry about this term. Now come to first term. This is 1 by L. Applying the upper limit, you will have L square by 2. So cancel 1 L. Now minus of minus 1 by L is there. Minus of minus, this term will be plus, and you have a constant L by 2 n pi. Now integral of this term. Once more integrating, this is n pi into cos 2 n pi x by L divided by 2 n pi by L between the limit 0 and L. Cancel this one. You have L by 2 plus L by 2 n pi square, then cos 2 n pi, you have cos 2 n pi L by L minus cos 0 . So this term will be cos 2 n pi means this is equal to cos 0 itself. This term also will be cancelled. So what remains is this is going to be 0 because this is equal to 2 n pi means the value of 2 pi. 2 pi is cos 0 itself. So cos 0 and cos 360 are equal. So cos 2 pi means it is the multiples of cos 360. So both are equal. So this is just like 1 minus 1 is equal to 0. So this is equal to L by 2 itself. So expectation of x is L by 2. Okay, let us just go back. Yeah, for calculating the expectation value, we wrote the definition, substituted the value of psi star and psi. Then we gave the value of sine square theta in terms of cos 2 theta. And then separated the two terms. That is, we have integration of x and x cos 2n by x by L. Integrated it separately. From the first term, you have integral x square by 2, applied the limit. So you have L by 2 here. And the second term, why we have to integrate it by parts. And when you integrate it by parts, the first term will be 0 when you apply limits. And the second term is integrated again, and you will obtain in that case also, when you apply limits, that becomes 0. Both the value given with upper limit and that of lower limit are equal, so that also will be 0. So expectation of x is L by 2.